Okay, we're going to go into understanding the basic descriptive vocabulary of molecules with functional groups. We're going to draw the line structure of a ketone with 6 carbons in the main chain with 2 methyl group substituents. And there's a lot of different ways you can do that. So we're going to start basic. This is a skeletal line structure, and each point represents a carbon. So there's a carbon here and here and here, 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 and here. So if you count 1, 2, 3, 4, 5, 6. Now we're going to go add 2 methyl subscripts. A ketone would be a double bound oxygen anywhere in the middle here. And then 2 methyl subscripts would just be a line out somewhere in the middle. Now this is one way we could draw it, but there's other ways that we could draw it. Now my ketone groups are not real pretty because I'm drawing it on a computer screen. They're a lot prettier when I draw them on paper, but this is what you could do. Okay, let's draw some others. So here we want another ketone with 6 carbons and 1 methyl group substituent. So again, 1, 2, 3, 4, 5, 6. A ketone with a double bound oxygen in the center, and then a methyl substituent. So we could put that methyl anywhere. We could put that ketone on any one of the middle carbons, and that methyl group could be on any one of the middle carbons. So we can move those around. You can see like this anywhere. Here we have, they want an alcohol with 5 carbons and 2 methyl groups. So again, we draw 5 carbons, 1, 2, 3, 4, 5. So it looks like an M. And then we're going to put an alcohol, which is an OH. It can be on the end or it can be anywhere in the middle. For our beginning of this organic unit, we're going to put it on the end. We'll talk about others in 1120, but we're going to put it on the end, and then we're going to put 2 methyl groups. Now they can be on any of the middle carbons. If I put it on the end, it makes it a 6 carbon group. So we want to make sure, or 7 carbon group. So we want to make sure we put them on one of these 3 in the middle. But I can do it like this. I can do it like this. So there's a lot of different ways I could put it. I could put those 2 on this center one also. So there's a lot of different ways I could have drawn this. So there's more than one way to draw these. So here I want to draw a line structure of an aldehyde with 5 carbons and no substituents. So again, 5, and an aldehyde is a double bound oxygen on the end. So double bound oxygen with an H. And there's really no other way to draw that because the double bound oxygen does need to be on the end. To do a ketone with 6 carbons, again in 1 methyl group, we're going to put a double bound oxygen in the center. So we're going to do 6, 1, 2, 3, 4, 5, 6, and then we're going to put the double bound oxygen on one of these center carbons and a methyl group coming off. There's a lot of different ways to do that. So again, my ketone groups are not real pretty. That one's probably the prettiest. All right, so here we've got a carboxylic acid, this time with 6 carbons and 2 methyl groups. So carboxylic acid needs to be on the end, and it needs to have a carbonyl group. So we're going to go do our carbons first. So 1, 2, 3, 4, 5, 6. We're going to do a double bound oxygen, and that should be an OH. Let me fix that really quickly. That should be an OH. So carboxylic acid has an OH. And then we need 2 methyl groups, and so we should have, and all these should have an OH. Oh, bad. So to be a carboxylic acid, it has to have an OH. I have an aldehyde there. So let's make sure we do an OH on all these. Let's fix that one that didn't want to do. I don't know why that did that. So all those should have an OH. Okay, Let's go ahead and go forward. And that's the end for that one.